Hey there, we're going to take a look at the comparator circuit first of all. This is the comparator schematic that you're going to be building on breadboard. I've tried to color code the wires as much as possible so you can see how the schematic relates to the breadboard. We start with the LM311 comparator, and we note that pins 4 and pin 1 tie to ground like so. You can see 1 and 4 here, and this is going to be your ground line here. Power goes to pin 8, and the power is also connected to pin 7 through a 1K resistor, and that's shown here. So we see the power is going to come into the circuit breadboard there to pin 8. It's going to connect to a spare track here, and it's going to go through a resistor to pin 7 like so. And then we've got the threshold setting resistors, these two 1K resistors here, and with a 5 volt supply we're going to have a threshold of 2.5 volts on pin 3 there. You see that coming down. Later on I do a simulation and show you how to connect up the function generator and how to connect up the oscilloscope. But in terms of building this on breadboard, this is all you need for a plan. Power supply you're going to use in the lab. This part's very quick. I'm setting the circuit up in multisim. You can slow it down if you need to, just to see where the various components are, but it needs to be done quickly, otherwise it becomes quite tedious for anyone that's watching. There's a bit of information along the bottom there you can read on comparators as we go through, and you can become familiar with some of the various terms that are used with comparators, such as inverting and non-inverting. Here I'm setting up the function generator. There is an offset voltage required for this test of 2.5 volts DC, and riding on that 2.5 volt DC level we're going to have a 100 millivolt sine wave, and it's set up at 1 kilohertz. Now I'm setting up two oscilloscopes to measure the input and output. I'm setting up two because I want to show what happens with the DC level as well, and because we haven't got three traces on a scope, I need to set up two, so I'm setting them up. Here I'm setting up the time per division. They're both going to be 1 millisecond per division because it's a 1 kilohertz signal. Same for oscilloscope 2. You'll notice on the bottom oscilloscope I'm going to set the coupling to AC, whereas on the top oscilloscope it's set to DC. When we set the coupling to AC, it makes it much easier to zoom in on small waveforms. 100 millivolts not a particularly small waveform, but it's a lot easier for you to see in the simulation as opposed to the threshold. So now we do the simulation. That was a sim, very quick course. Here I've got a paint version of it, so you see the threshold voltage, that's the voltage or it's sometimes known as the reference voltage, and that's connected to one of the inputs, and the function generator voltage is the one which varies. This is set up on AC, so it's not a true representation in terms of DC, but it varies, and you can see that as it falls below the threshold voltage, the output of the comparator switches off. And as it rises above the threshold voltage, the output of the comparator switches on. And effectively, that is the basic function of a comparator. It compares two voltages, the threshold or reference voltage, with a varying voltage, and its output switch on and off accordingly. Now we can see just a little bit more. What I'm doing here is I'm changing some of the circuit parameters. For example, changing the DC level, or changing the value of the threshold setting resistors R1 and R2, just to see what happens to that waveform. You see that if we just take it a little bit outside of its normal parameter, it either switches on, switches off, or it changes the value of the waveform. And you can experiment with this yourself just to see what happens. On a practical circuit, when you build this practically, it would be far better, in actual fact, to just use a potentiometer instead of the two resistors, because then you've got infinite variation. Now we're going to set up the oscilloscope. We're going to use channel 2, and we've got channel 1, so I'm showing you can adjust the positions there. Those give you the menus. We're on channel 2 setup at the moment. You want coupling DC. Probe should be 1 times. Channel 2 should be 2 volts. And channel 1 should be 100 millivolts. That's for that one. And finally on the function generator, that's near enough to 1 kilohertz. That's where you adjust it. We set a range. I've got the 3 kilohertz range, so that will sweep between 0 and 3 kilohertz. Main out, we're going to use 50 ohms. Doesn't really matter too much for this circuit. Amplitude set there. When you come to do this practically, you're not going to be able to use a 100 millivolt waveform. You're going to have to use the smallest I could get it to was 1.4 volts peak to peak. That's with a 2.5 volt DC component or DC level. You see the offset, so when you switch the offset button it shows you the offset voltage, DC offset, and when you switch the peak to peak button it shows you the peak to peak voltage. Okay, hope you have fun with this one. Goodbye.